Today, we're going to see how we can make easy, simple CRUD operations with web requests from our mobile applications, all using the power of C#. So tune in. Hey everyone, I'm James Montemagno. I'm back with another Xamarin 101 video. I'm real excited about this week's because we're talking about web requests using HTTP client, the ability to take all those awesome bits of stuff on the internet, pull them down into our mobile application, but also at the same time, not only get data, but also post data too back to a web client. If you're brand new to the channel, I'm glad that you're here. We've been building out awesome mobile applications with Xamarin, C# and .NET, and I have a whole Xamarin 101 video series I'll put up over there in the corner, but make sure, of course, you subscribe and ding that notification bell because I put out videos every single week right here on the channel as we guide through our learning journey together. All right. So today, what are we going to do? Well, we're going to take a look at how we can use HTTP client, which is built into .NET itself, to make web requests into an ASP.NET Core Web API. Of course, you can do it with any web API. It doesn't have to be ASP.NET Core, but since I'm a C# and .NET developer, that's sort of the beauty, is that I can build my mobile applications, desktop applications, and my powerful web backends and even microservices and all that good stuff. Now, I'm not going to walk you through how to build that backend. I'll kind of show you it's the easiest web API in the world, but we do have great documentation and things like that. So I'll show you what that looks like. And then I'm going to pull down that data, upload some data, give you some of my best practices, and additionally, how to store and cache that data locally. At the very end, we'll talk about data synchronization. So tune into that. All right. Now, I want to show you that we have tons of great documentation and learning paths on Microsoft Learn and, of course, onto our docs, but these are self-guided learning paths, anything from learning C#, creating web APIs, building mobile applications, all sorts of good stuff. You can browse through all the different learning paths. There's all sorts of great stuff here. And if you were just to put in like an API in here, you'll see create a web API with ASP.NET Core and even one for Swagger, which is a really cool way of adding documentation with OpenAPI. So I have published my ASP.NET Core backend to the internet. It's here, and this is Swagger. And Swagger is sort of like a automatically generated browser of APIs. So here we have the verbs get, post, get a specific ID, put, and then delete. So those are like the different ones. So get is obviously get. Post is to basically insert or add a new item. Here, get with a specific ID is going to get a single item. And then put is actually a little bit different. Put is please update this item. Okay, so put is to update an item. And then delete is obviously to delete. So here, what's nice about Swagger is that you can actually come in here and execute and test out the API. So for example, this is the API, motscoffee.azurewebsites.api/coffee. And if I zoom in here, you'll see that it returned a single JSON blob back to me, okay? And what that does here is it just visualizes it very nicely. So I added one by default right there. I can also come in and I can also post. So here I could actually add another one if I wanted to. I could give it a new ID and then I could say 2 and then hit execute. And if I go back over here and hit refresh, now it's going to have 2 items. Same thing if I scroll up top here and go ahead and hit execute on my get, it's going to now return 2 of them back in a JSON blob. So what we want to do is not only be able to test our web API client, we also want to be able to put this into our mobile application. So let's go ahead and first look at our web API. I have a simple, very simple web API over here. It's this one's built with .NET 5, and it's simple ASP.NET Core web API. You can see here's .NET 5 right here. And what I've done is I've actually shared my coffee model with my mobile applications and my web API. So that's actually kind of nice, as you can share code between your web backend and your mobile applications. So this coffee application is crazy simple. It's actually just built in. Here's the route API/controller, which is basically /coffee. And there's very simple gets. I have a static list of coffees. All it's doing is get a specific one, posting, adding a coffee, putting, updating a coffee, deleting a coffee. So really nothing special there. It's just a blank web API canvas, nothing like that. I did publish this to the internet to make it easier just to kind of show this off. I will talk about local debugging, which is awesome. And what I've done here is if it's in release, I've also added Swagger and HTTPS in there, which is kind of nice. You don't have to do that. You can just only have it in debug mode, development mode to add Swagger, which is that definition there. So what else do we have? Okay, well, we've pulled out our coffee. Now we're sharing just the simple model between our web API and our mobile app. But I've also created a Internet Coffee page, an Internet Coffee view model, and an Internet Coffee service. So previously we had a coffee service, and this was pulling from a SQLite database that we can see here. And it has add coffee, it has remove coffee, and it has get coffee. So what I've done is I've basically duplicated that here, and I have Internet Coffee, and we're going to get coffee, we're going to add coffee, we're going to remove coffee, okay? Now, at the same time, I've also created an internet view model, and it is actually the same exact view model as my coffee data offline cache that's stored. This internet one, the only difference is that when I hit add on the UI, it's going to add it to our Internet Coffee service. It's going to remove it from our Internet Coffee service or simply get it in the refresh. So very, very simple. And of course, I could add updates and things like that too. Okay, so let's get started. This one's really simple. We're going to start in our Internet Coffee service here. And here what I've done, and I want to show this off to everybody, is that I have a just base URL. Give me the base URL where my API lives so I don't have to type it over and over again. And if I'm debugging locally, all right, this is really important. Android emulators don't talk on localhost, but they talk on 10.02.2. And on iOS, it talks on localhost as long as you're on a Mac, of course. Now, for this purpose, I just published it really easily to a free tier on Azure, so I could go ahead and give it a go and have a base URL here. Note, though, that it's really complicated to debug HTTPS locally, certificates, all this stuff. It's really messy. So what I do is I go ahead and I turn off HTTPS for local debugging on my backend, so that way I can debug it locally. There is a little bit of setup that you need to do in your iOS and Android application to allow clear text, but I'll put links down below so you can read up on that. It's very easy to do, just a few config files. So this is my base URL. And for right now, I normally have an interface and I have some dependency injection stuff, but I'm just going to create static stuff. So I'm going to create a static, then I'm going to create an HTTP client. Okay. I'm just going to say client here. There we go. And an HTTP client is sort of this base class for doing HTTP requests or REST requests off to our backend. And we have all sorts of stuff in here. So the first thing we're going to do is just create it. And I'm just going to create it in the static constructor. I'm going to say new HTTP client. Now, on the client itself, if I zoom in here, we can see that I can do client dot, okay, and I have get async, send async, post async. If I go down here, I also have delete async, which takes in a URL request, get async, again, like I said, get stream, get string. There's all sorts of different helper methods in here, post, put, send. So these are things that are very similar to those verbs that I just showed you, okay? And you have timeouts, you can really control this. Now, if you don't specify a base URL, you'd have to enter that URL every single time. So what you can actually do here is you can give it a base address, all right? And you can say new URI and give it this base URL. So that's kind of nice. So you don't have to post that URL every single time and concatenate it. It's going to say this client here is for this URL no matter what. All right, let's just start really simple, okay? Let's just get our coffees. So all I'm going to do is say var JSON. I'm going to say await client dot. And in here, I have a few ways of getting data. I have get async, get byte array async, get stream async, or get string async. Now, the get async is just generic. It just gives me a message back, and we can use that in most instances when we don't know what we're getting back, but I know I'm going to get a string back here. So I'm just going to go ahead and say get string async, and my request URL is API/coffee. That's it. because again, remember, it knows that I already have that default URL that's in there. So that's going to get back a string. And if you remember, if we open up the browser one more time here, it's going to get back this string, which is an array of coffees. Now, we'll also have to deserialize this JSON from the internet, basically. And you can use json.net or newtonsoft.json to do that, or any other JSON deserializer that's out there. But we're just going to use JSON in here, json.net. So we're going to say var coffees here. I'm going to say JSON convert dot. In JSON convert, I'm going to bring in newtonsoft.json. And I can say deserialize object. And this is going to be an IEnumerable of coffee, because we know it's an IEnumerable coffee, right? That's how we know it is. I'll just pass in JSON. And then I'll return those coffees. Boom, just like that. So now we have our API, our coffee, and our coffee's coming back. And just like that, what I want to do is just debug the get first, okay? And then we can look at the add, and then we can look at the delete as well. So remember, very simple, literally two lines of code. It gets the string asynchronously, deserializes that object asynchronously back, and that's it. This is sort of the base of every application I've ever written, ever, for all intents, I would say. That's sort of important to kind of know. All right, so here our application is launched now. So I've added another item in the flyout menu, so we can now come into our internet coffee. I'm gonna go ahead and pull to refresh here. Now this is gonna make that web request off into the internet. There we go. Let me go ahead and minimize this down. And we can see that I have my coffee right here. Look at that. I have the two items coming right in, which is really, really cool. Now, if I go ahead and simply step over this, we're going to see that I have the two coffees. Check this out. So very, very simple. I have the delicious coffee and then the delicious coffee number 2 from the second internet roaster. And then just like that, we have two different coffees right there at our disposal coming from the internet. We just made our very first web request and we are good to go. Okay, now that we have gone ahead and gotten the coffees, let's go ahead and insert a coffee. So we can insert a coffee pretty easily. What we need to do is come in and make another web request. So let me go ahead and zoom in here. So I'm going to say var response equals await client dot. And here, instead of doing a get, we can do a post async. All right. Now, post async takes in a request URL and an HTTP content. There's different types of HTTP content, like streams and strings and objects. We can actually pass it string content and we can pass it JSON because we're able to do that. And automatically our server will be able to deserialize that, which is very nice. So our API is actually going to be the same as before, API/coffee. And then what we want to do here is simply pass in some content, okay? So what we're going to do is we're going to say var JSON equals, and again, we're going to use JSON convert dot, and we are going to serialize an object, sorry, and pass it the coffee. So this is the coffee that I created right above. And again, this may not be the best practices of creating a randomly generated ID. You should probably let your server handle that, but for this instance, we're going to do that. And now what we can do is we can say var content equals, and we're going to say new string content, okay? And here we're going to give it some strings, which is our JSON. We'll give it encoding, so we'll say encoding dot UTF-8. And then what we need to do is give it a media type. So let me go ahead and put this down on a new space here. And this is going to be application/JSON. Okay, there we go. So that's going to be the content that we send in. So var content response, and what we can do here is we can say if not response dot is successful. We can get the headers, status code, successful status, all that good stuff. We can go ahead and do something. And that's really simple. And this is a little bit more complicated because we're passing it data, right? We're actually sending it up there. Compared to this get, which is like, hey, give me the object, send it back down. Now for the remove, we can actually do a very similar thing. We can actually just do not do a post, but we're going to use another verb, which will be delete. So we have our post, and here what we're going to do for delete is say await, and then client dot. And if we zoom in here, we can see that I have a delete async. Now this does return an HTTP response for me. So I can do the same exact thing. I could say var response equals, and then here I could say the request URL. In this instance, we can use some string interpolation. And what I'm going to do is say API/coffee/ID. Because again, if we looked at the coffee controller, it's going to tell us it's API/coffee/the ID. And that's how it's going to look it up and delete it from the list. So that's all we really need to do. And I could do the same thing here. I could say if response is not successful, yada, 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 go to town there. So let's go ahead and test this out and add some breakpoints and actually debug it. Okay. So what we're going to do now is we're going to go off, serialize it, add our new coffee, but also have the way of deleting it. So let's go ahead and get this up and running now. There we go. So far, not too complicated. Hopefully we have simple, REST commands that are out there, and then our application's calling them with the HTTP client. So here's Internet Coffee. Let's go ahead and pull the refresh here, and we should get back our 2 coffees, coffee 1, coffee 2, and let's add one, and I'll say my coffee, and then that's the name, and I'll say roaster James. Hit OK. This is going to go off. It actually just made the web request. It was successful. I can actually look at all the stuff there. Hit OK. It's going to hit my refresh code. So it's going to go off, refresh the data from the database, and boom, there's my coffee. And I can prove that it's actually in our backend because if I go here, hit execute, here we go. Internet Coffee, James Coffee coming in. Now, if I come in and I hold this down and hit delete, it's going to do the same thing. Remember, we made our delete API coffee. Our response was OK, successful. Hit OK here. And if we go back into our backend again now, hit execute, we can see that coffee is gone. It's completely gone, and it's gone from our application, which is very, very nice. Boom, good to go. So far, what have we learned? Well, we've learned that we can use HTTP client, which is built into .NET, just built right in there, and JSON convert, and with part of Newtonsoft.json and JSON.NET to serialize and deserialize and get our objects from the internet, which is super nifty in my personal opinion. Now, there are some other cool mechanisms, like if you have a Swagger definition, you can automatically create a client and it'll do a bunch of stuff for you that's built into Visual Studio. I'll link to another video that I did with my buddy Glenn talking about that. You can also use some other nifty APIs out there, like Refit is a really cool one that you can go ahead and have it generate very simple APIs. I wanted to show you the basic building blocks, and there's amazing .NET libraries that do a bunch of really cool things. Now let's talk about one other thing here, which is how do I cache my data, right? What if I'm offline? I'm completely offline here. What do I do in that case? Well, first, you should probably try catch all of these things, because if you're offline, it's going to throw an exception and bad things are going to happen. So you definitely want to do that for sure. But you can also cache your data locally. You can put that in a SQL database, but I'm not about sometimes caching the data locally and storing the objects. I want to cache the web requests. So in this instance, since we're just talking about online data, I'm going to go ahead and use a library I created that is called Monkey Cache. So Monkey Cache, actually, if you just go to browse or your NuGets and type in Monkey Cache, one word, there's a bunch of different versions of it. I've installed the file store, which just saves different files to disk in the correct place in the cache. There's also a SQLite version and a LightDB version, so you can pick and choose what you want. I like the file one. It's very, very simple. So Monkey Cache is a cache. It's not a database necessarily. It's not meant for that, but it stores your information in a cache library. So if your users, upgrade their device or the system wipes it out, it clears it out. But it's good for caching web requests. The only setup you need to do is inside of your application startup and set the application ID. So this gives it a folder to put the data into. And you put everything into this barrel, all right? And that's sort of the basis of putting items into barrels with different keys. There's also a few other libraries I'll talk about later that do some similar things, but Monkey Cache is the one that I built, so I sort of like it. So let's go back into our Internet Coffee service here. And I'm just going to do obviously the web request caching for the get, because here, this is going to make the web request every single time. So here's what I'm going to do is I'm actually going to add a little helper library, not library, but a little helper function here. And what this does is it says get async, and it's generic. So you can reuse this method over and over again. Give me a URL, give me a key, and give me how many minutes you want this to be valid for. And if you want me to force refresh this, basically ignore the cache. So this is pretty cool. I'm going to bring in my monkey cache library. There we go. And what this does, it says use Xamarin Essentials and see if I have network access. If I don't, get the information from the barrel. All right. Now, if there is information in the barrel, then go ahead and just deserialize that object asynchronously. Else, go make the web request like we saw earlier, add that into the barrel, and then simply go ahead and return that object. And if something goes wrong, let me just go ahead and deserialize this here. So easy peasy. So this is really cool. So now what we can do is we can come into this get coffee, and now what we can say is get async. I'm going to say IEnumerable of coffee. And what this is going to do is give me a URL. So API/coffee. All right. Key, I'm going to say get coffee. So whatever you want it to be, that's the key it's going to use. And we are going to simply say, use the default. So minutes, 1, et cetera, et cetera. And here, now that it's just asynchronous, I can return the get async. And now if I have more gets in the future, I can simply reuse this over and over and over again. So now let's go ahead and run this and see how this works. So all built in, you can reuse this get method over and over and over again. I like this generic version of it here. Okay, so let's launch the application. And what we're going to do is we're going to go ahead into Internet Coffee, and I'm going to hit refresh. Now, this will be the first time that it actually gets data, so we can see that the data is empty. And then what we're going to do is get that information, store it locally because we've gotten it from the internet. There it is. And then I can continue on. Now, we've cached this web request for a minute. So if I actually pull to refresh again, it's not going to make that web request call. We can see here that this got the cache right here from the barrel. So it went and it grabbed it, and we're good to go. Now, in this instance, it's going to return it and just pop it right back up into our UI. But what happens if, let's say, I close the application, I put it into airplane mode, and then relaunch it again? Well, now, because we have monkey cache here, it's going to detect if I have internet or not with Xamarin Essentials, and it's going to return that list directly back to me. There it is. I've now cached those coffees offline for as long as I need to, because it doesn't check the expiration. It's just always going to be there. My application is good to go. Now, it's very similar in this instance, like reading it from the database. But here, this could be for any web request. It could be, any data that you just want to make sure your user has available to you. It's one way and another tool in your toolbox. All right. Now, there are a lot of other mechanisms out there for getting data, caching data back and forth. Some things like Akavash are really good. It gives you a lot of persistent value, key value store. Monkey Cache is here. There's a lot of other databases that are out there into the world that you can use, because the next question becomes, well, what about online and offline data synchronization? I get this question a lot, and there's a lot of ways of accessing this, right? And actually making online and offline work. There's a lot of services that you would need to register for if you didn't want to create your own. In this instance, we could have a internal ID that we use locally and a web backend API. If we store it in Entity Framework into a SQL database, we could figure out how to upsert, and delete and, update all of our different database coffees locally and our backend. Totally possible. Most likely what you would do in that case is have some sort of hash that was unique, and then you would have like a dirty flag. So if you're offline, you could say, I need to update this later, do some synchronization. There's plenty of services out there like Realm, like Azure mobile apps, Firebase. and a bunch of other ones out there that you could use and sign up for that would automatically do online, offline data cache where you need it. A lot of my applications just make GET requests. They often are just pulling data from the internet and displaying it. So this sort of works for me. Now, of course, your application is different. So again, there's a lot of different resources out there, and I'll put links in the show notes below to actually check all that out. Anyways, I hope that you found this video interesting. It's a little bit longer form, but I wanted to go through basic REST and HTTP and making these web requests, and of course, even caching those web requests offline with Monkey Cache, which is a really fun library, and it's all open source, so you can take a look down in the show notes below. Well, hope you enjoyed this Xamarin 101 episode, and hope that you check out all the other Xamarin 101 episodes here on the channel. I definitely love hearing from you and reading all of your comments, so please leave some comments below. More importantly, if you do love this video, give it a thumbs up. That goes into the Google algorithm of YouTube goodness and recommends it to other people. And don't forget, of course, to subscribe and ding that notification bell so you get up to date on all the latest episodes I put out. Anyways, thanks again for watching. I hope you have a good one, and cheers.